Introduction. Differentiation is a process of finding the derivative or rate of change of a function. The derivative is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to the function at a point.
Let's look at this question. Given the function f(x) equal to negative x divide 1 negative x plus 4. A. Find the x-intercept and y-intercept. So, for the x-intercept, f(x) equal to 0, negative x divide 1 negative x plus 4 equal to 0. Negative x equal to negative 4 in bracket 1 negative x. Negative x equal to negative 4 plus 4x. 4 equal to 5x and 4 over 5 equal to x. So, for y-intercepts, f in bracket 0 equal to negative 0 divide 1 negative 0 plus 4. So, y-intercept is 4. Fx equal to negative x divide 1 minus x plus 4 equal to negative x plus 4 in bracket 1 minus x divide 1 minus x. So, the answer is 4 minus 5x divide 1 minus x. So, we do vertical asymptote. Let 1 minus x equal to 0. So, the answer is x equal to 1. So, we do that analysis of vertical asymptote. Lim x approaching 1 minus 4x equal to limit x approaching 1 minus 4 minus 5x divide 1 minus x. So, the answer is negative infinity. And limit x approaching 1 plus fx equal to limit x approaching 1 minus 4 minus 5x divide 1 minus x. So, the answer is infinity. So, we do the horizontal asymptote. Limit x approaching plus minus infinity fx equal to limit x approaching plus minus infinity for negative 5x divide 1 minus x. So, we got the answer is y equal to 5. F prime x equal to vu prime minus uv prime divide v square. So, we got negative 1 divide in bracket 1 minus x square. So, let f prime x equal to 0. We got 1 equal to x. So, we have two interval which is in bracket minus infinity to 1 and in bracket 1 to infinity. So, increasing interval equal to 9 and decreasing interval equal to in bracket minus infinity to 1 union 1 to infinity. F prime x equal to minus 1 divide in bracket 1 minus x square. We got the answer is minus 1 in bracket 1 minus x power of negative 2. So, f double prime equal to 2 in bracket 1 minus x power of negative 3 in bracket negative 1. So, we got the answer is minus 2 divide in bracket 1 minus x power of 3. Let f prime x equal to 0. We got the answer is 1 equal to x. So, we have to an interval which is in bracket minus infinity to 1 and in bracket 1 to infinity. So the concave up is in bracket 1 to infinity, and concave down is in bracket minus infinity to 1. For E, find the inflection points. So x equal to 1, f in bracket 1 equal to negative 1 divide 1 minus in bracket 1 plus 4. So we got the answer is undefined, which is a math error. So inflection point does not exist.
This is our graph for function f(x) equals to negative x over 1 minus x plus 4. As you guys can see, we have two coordinates, which is x coordinate 4 over 5 and 0. For y coordinate, we got 0. And for this is a rational function graph where the graph didn't touch the line asymptote.
So next, we move on to question 3. Given the function f(x) equals to negative x cubed plus 9x squared minus 24x plus 2. So first, we need to find the first derivative of function, which is f prime x equals to negative 3x2 plus 19x minus 24. Next, we need to find the x-intercept. To find x-intercepts, the x value must be 0. So we get 0 equals to negative x cubed plus 9x2, negative 24x plus 2. Then we get 3 value of x, which is 0.09, 4.46 and 4.46. So next, we need to find y-intercept. To find y-intercept, x need to be 0. So we get the function f 0 equals to negative 0 cube plus 902 negative 240 plus 2. So we get y equals to 2. So next, we need to find the critical value. To find the critical value, we need to find the x value first. To find the x value, f prime x needs equals to 0. So we get negative 3x2 plus 18x minus 24 equals to 0. Then we get x minus 4 and x minus 2 equals to 0. And we get two value of x, which is 4 and 2. Next, we need to find the value of y. To find the value of y, we need to put the value of x into the equations. And we get f2 equals to negative 2 cubes plus 2 9 square negative 24 2 plus 2, and we get negative 18. Next, we need to find the another value of y. To find the another value of y, we need to put another value of x, which is 4, into the equations, and we get 4 equals to negative 4 cube plus 9 4 square negative 24 4 plus 2, and we get negative 14. So we get the critical points, or we get the maximum point also, 4 and negative 14, and the minimum point is 2 negative 18. So next, we need to find the increasing interval and the decreasing interval. To find the increasing and the decreasing interval, we need to put the value into the table, and we get test value for 0, or for the interval of negative infinity and 2, we get the sign of function if negative. At the interval of 2 and 4, we get the test value 3, and then we get the sign of function, which is positive. And the last one, the test value is 5. From the interval 2 and infinity, we get the sign of x, which is negative. So next, we need to find the second derivative of functions. To find the second derivative of functions, we need to put the first derivative of function, which is f prime x equals to negative 3x squared plus 18x and minus 24. Then we get f double prime x equals to negative 6x plus 18. so that we can find the inflection point. To find the inflection points, first we need to find the inflection value. To find the first inflection value, we need to use the second derivative of function, which is negative 6x plus 18 equals to 0. And after some calculation, we get the first inflection value, which is 3. And for the second inflection value, we need to use the first derivative of function, which is f prime x equals to 3x2 plus 18x negative 24. We put the 3 into the x and we get negative 16. So we get the inflection point, which is 3 and negative 16. So next, we put the test value 0 from the interval negative infinity 3, and we get the signs of function, which is positive. And next, we put the test value of 4 from the interval 3 infinity, and we get the sign of function, which is negative. So we get the concave up is negative infinity 3, and the concave down is 3 infinity. So this is the graph for the function fx equals to minus x3 plus 9x2 minus 24x plus 2. So from the graph, we got 3 coordinates. So the first coordinate, which is 4 and negative 14. The second, 2 and negative 18. And the third one is 3 and the negative 16. So that's the 3 coordinates we got from the graph.
Application in real life for analysis of function. Functional analysis methodology is a well-established standard for assessment in applied behavior analysis research. Although used less commonly in clinical non-research application, the basic components of an FE can be adapted easily in many situations to facilitate the treatment of problem behavior. Function in real life is frequently used. Examples of function in real life include estimating animal populations and determining risk factors for insurance rates.
This method is really helpful and advantageous when it comes to handling business or other difficulties that call for computation in our daily lives. It is important to remember that a function may not change concavity at a point x even if function is undefined. In conclusion, we can determine the concavity of a function f by taking a look at the second derivative. We observe that a function can switch concavity.